Hi class, in this video we'll be looking at creating our own classes using the class statement to create user-defined classes that we can use however we like. Here are our objectives. And what we're really concerned with when we're talking about object-oriented programming is the object, the concept of an object. Whenever we look at a solution in Visual Studio, we see a collection of projects or files or different things depending on how we're looking at Solution Explorer, but we really can think of these as cooperating objects. The class serves as a template from which we can create many objects. So some important things for us, concepts to learn. Abstraction. Abstraction is where we take the data and behaviors of an object and turn them into an abstract concept that we can design or use in a program. So let's back up here and open our OneNote notebooks and add some notes. I'll create a notes section and a syntax section, and of course we can always add more, right? Now in our notes section, first of all, we can put something that an object equals a class. And this is pretty important, so I'm going to make it bold and big and something that I'm going to see when I bring up my notes. So we've seen a class statement already in our code quite a bit, so we know what the syntax looks like. We'll go over and make a note on that, but I think we have that already in our notes for Chapter 1. Now, when we're looking at a class object, one of the components that is important to us is abstraction. The object is defined in an abstract manner. So let's think about abstraction. What is that? What does that mean? I could Google that term and bring up a dictionary concept or definition. But let's look at some images. Abstract images. You know what an abstract artist is? Is an artist who creates things in an abstract mode, and then we sort of get what we want out of it. But all of the details are not necessarily included. It's abstract, right? So that makes us think about what that term means. So an abstract class, that means that we are working on this object, but you know, it's kind of virtual. It's not really real. It's just abstract. And some other points they want us to know are that the attributes and the behaviors are an important part of that abstraction. So I have abstract attributes and behaviors. And we'll get a little bit more into that as we go. Now, whenever we're working with a class, we're going to create those attributes, the attributes of the class, as private data members. So for example, if I want to create an animal class, let's do that. We'll create it later in another video, but let's think about it here. I'll draw something. Maybe I'll insert a shape. How's that? You know, my drawing. And in my shape, I want to put some text that says this class is going to be my animal class. And I'll make that bold. And some of the attributes for my animal. I'm going to have the type of animal, like a cat or a dog. I'll have what the animal says, like meow or woof woof, depending on what kind of animal I have. Let's do a couple of other things. What else do we want to keep track of about our animal? These are attributes of an animal, and we can create an instance of this animal by using our class in an abstract way. So I have the type of animal, what the animal says, maybe its color. That would be a good thing. Maybe if it's an indoor or outdoor kind of pet. I'm sort of assuming that these are pet type animals. So all of these are attributes of this animal. So these attributes are going to be private to our class. So since these attributes are going to be private, in our UML document or diagram, we'll put a minus sign at the beginning of each of them to say these are private attributes. Now I'll fight with OneNote a little bit more because my private attributes are going to be named starting with a lowercase letter. And I might be changing a little bit, right, because I still have some spaces and things that I need to fix up to make those valid variable names, but I can do that. So those are my private attributes. Those are things that I'm going to care about if I'm looking at one of these animal objects. These fields that I have that are attributes of my object are going to be declared inside the class, but not inside any specific method. So that means that they're going to be visible to all members of the class or global to the class. They're going to be class level variables. And these things are always going to be defined as private. So let's add a little bit more. Our attributes are private. They're going to be class or instance level variables, which makes them global to our class. What else? I think we got it. Everything that we need, it's inside our class. So in this example, is in REPL for you to complete. So please do that as extra practice, and then you'll want to complete it in Visual Studio also so that you get that additional practice. This class is going to define a student as an object. And if we're looking at a student, there are things that we want to know about students, like their names and maybe their numbers. And in this case, we want to know 3 of their scores and what major they've declared. So we can add this class in Visual Studio very easily in several different ways. We could type in the code, but I'm going to show you how they do it, and I want you to walk through this on your own. When you go to the Solution Explorer, you can add a class to your project. Then you can find the class diagram area in Visual Studio and type all this information in. And your textbook steps you through this, so that's why I'm going to refer you to that information. This is what that class details window looks like that you'll be using. You can type in all of these fields for this student and say that they are private. In our other video, we'll do this for our animal object. Now, they continue with creating their student object by creating some methods or some actions that go along with this student object. Whenever we create a class object, we have what's called a constructor. And a constructor can be thought of as kind of the entry point to this class, or how do we get it built? It's kind of like the mold. What kind of information do I have to supply to create this class instance and a specific animal in our animal class? So a constructor is just a method. It doesn't differ very much from any other method, except that it doesn't have a return value. So it doesn't include the word void because it just doesn't include a return value. Constructors have to be named exactly the same thing as our class, and constructors are public. So if we look at our OneNote diagram here for our animal, we've said that we're going to have these types of private variables. Well, we're going to have some actions. We're going to have a constructor, and it's going to be called animal, and it's going to be named exactly the same as our class. Down in the bottom of our UML document, we put all the methods or actions. Well, constructing an instance of our class is an action. So let's put a little bit of notes here. Constructor. It is a method with the same name as the class. It has no return type, not even void, and it may or may not have parameters. We'll see how we'll use those. And it's used to create an instance of our object. And that's called instantiate. So for example, if I had a class that defined people and I wanted to create a people object named Joe, I could use a constructor to instantiate or create that instance of the people object named Joe. Joe's going to have certain attributes and characteristics, like his hair color might be brown, his eye color might be blue. All of these different attributes have to do with this specific instance of this person object. So very, very in-depth information here for us that we're using in our programming. It gets a little complicated at first, but it also gives us a huge amount of power. Now, constructors are always public because if anybody else is going to use our class, they have to be able to access the constructor to create an instance of our class. So now here is some syntax. In this example, we're creating an instance of the student object that they showed earlier. If we want to create a student that doesn't have any information, no student ID, no name, no nothing, it's just a null student, it's just sitting out there in memory without any sort of information loaded in it, then we can use this default constructor. And the default constructor simply says public, because it's a public constructor, and student, because student is the name of our class, and then it specifies that there's no parameters and it has no code. Now we could put code in there, that would be fine, but our default constructor in general doesn't necessarily need any code. Now the next example shows a constructor again with one parameter. So if a program is creating an instance of a student and it knows a student ID, it can create a student object with that given student ID by using this constructor. This constructor method then is overloaded because I can run it with no parameters, and I will run this instance, and I can run it with a parameter, and I will run this instance. We can continue on creating additional types of constructors to allow our users the greatest flexibility. In this third example, we can create a student knowing the student ID, the first name, and the last name. So we'll have a much more complete object created in memory from use of this constructor. No matter what though, we want these classes to be flexible and full-featured, so we want to have multiple constructors. Let's put that syntax in our notes. It's not super different from what we've seen before from our other method syntax. So we start out with the keyword public. Did that have an uppercase P? No. And we say our class name. So public class name, and then how many parameters we want, and then we have our opening and closing curly braces to indicate that that is the beginning and ending of the code body for our constructor. So this is a constructor for a class. It creates an instance of the class. It is the default constructor, no parameters. So sometimes you'll hear people call this a no param constructor. Now you can add additional information to your notes there about your constructors. But as we continue on with Chapter 4, we're going to think about some other ways that we can use methods that we already know how to create because we learned in Chapter 3. We can use those methods to access data from the class and update or mutate data in the class. And we can have other methods that we create to perform actions or behaviors of the class. So we have a lot of different instance methods. Now we get into this area in chapter 4, it starts being really important to look at examples. So as we talk through this, realize that we're going to look at an example as soon as we're through. So some important terms for us to get down. When we're using our own instance methods or methods that will apply to an instance of our class, we do not use the static keyword. We only use static if we want it to be a method that would apply to every instance of this class. So for example, my student name. I want to keep a different value for the student name for every student object that I create. So Joe is going to have his name, Joe. John is going to have his name, John. Gary's going to have his name, Gary. So those can't be static. I have to have a specific instance of that value for each instance of my class. Now, I could have a static method though. Maybe I have a method where I am just getting the first and last initials out of the name, just performing this action. Well, in that case, I can use that same code, that same method for each of those different students. I'll just be returning the result of my process as output to my caller. So in that case, it could be a static class or a static method. We'll see a lot of examples of those as we go. Now, when we're looking at our constructor again, remember it's a special type of method. It never returns a value. It never has void. It has to be named exactly the same as the class. Uppercase. Class names are always uppercase in C#. It is automatically overloaded. The default constructor is called the no-arg constructor. Now, when we created our class, we made all of the data elements private to our class. We're not going to let our data elements be updated by any other class. Some rogue class come along and try to update our instance variables and make Joe's name into Paul or something and get us into trouble. We're going to make sure that our data is hidden inside of our class. It's encapsulated. It's not available out to any other person or any other class, but sometimes we need to supply that data to others, and we do that through the use of another type of method, and this is just a plain old method called a getter, and a getter returns a value. So in the example that they show here on this slide, they're back to their carpet calculator example. We have a method named get number of square yards, and all this method does is return how many square yards are in the specific instance of this class. Why? This method is public. That means we can use it from outside of the class. So if I have a tester module that says I want to calculate how many square yards of carpet I need, I have a room that is this size, I could use this method, the get no of square yards, and it would return to me that value. So these accessor methods, again, are become much clearer when you start working with them. But these are also called properties when we're working with C#. Whenever we work with C#, our data attributes are private to the class, but we allow others to access those values, if we like, by using getters. Now, another option is a mutator. This is also called a setter. This is the same as a getter, only in this case, we're talking about updating the value we've saved in our class. So for example, let's say I have an employee class and I have an instance of my employee class named Sam, and Sam currently gets paid $20,000 a year, but he's going to get a raise. So my employee class allows other classes to use a setter method to update the salary so that we can set Sam's salary to the new desired amount. Now, Sam still exists as this one instance of this object out in memory, but now his salary has been set to a different value. Setters in C# are really important. These are ways that we can keep the data within our class protected, or again, encapsulated, so that nobody can mess with it. Here are some examples. Whenever we're working with a setter, we always receive a parameter that is some sort of value to use in this setting operation. Here, this first example, we have a method called set number of square yards that expects a double value to be passed to it, which is the number of square yards, and it returns a value. So this one doesn't do a lot of work, does it? Now, we also have an option where we could set the number of square yards being passed in a length and a width. And in this case, we might do some sort of calculation to get that number of square yards. They just want you to really notice how I'm going to have the same name, but I'm going to have different parameters as overloaded examples of that same mutator or setter method. Okay, so let's put that in our notes. We've got a lot of information here. So private class variables. This is our data. Public constructor to build an instance of the class. I like to think of the private data variables like when a place I used to work, we built a new building, and so all of the instructors got to have input into what the building was going to be like. But then as the building started getting planned, a lot of the input got cut because of expenses. And so the drawings for what the building was going to look like became very private. Nobody could see it. We had no idea what was going to happen, right? They kept that information private to the administrators and to the architects who needed it. So those architects that needed it, they would say, hey, I'm ready to do some construction. I need to know what you want me to do. And they would be given access to that private data of what this building was supposed to look like. And then they started doing some action. They started actually building the building, right? So we might have methods in an instance like that of, run wire, put up a wall. All of those different actions that happened. But I want you to really think about that in respect of how that data was private. Now, once people had access to it, once they were part of the construction, then they were given access to certain pieces of information that they required. They were given it through a getter. It was like, can I get a hold of that information? Sure, here you go. And then if something was wrong, if they found a problem where they said, well, the measurement on this isn't exactly right, there seems to have been some sort of mismeasurement, we better update that blueprint, which I got to tell you happens, then they would set that data, that blueprint, to a new value. We'll look at a lot of examples. It can be something that's a little bit difficult to grab your head around. Now, when we're working with our class, our getters allow public access to our class variables, and our setters allow public to update our class variables. So we can have a lot of things going on, but we can protect our data. Now we can also have some other methods, instance methods. Besides our getters and setters and our constructors, we can have instance methods. And instance methods perform some sort of action for our class. So in the example that they show here in this presentation, they're performing the action of calculating the average and returning that as a value to whoever made that call. Now, when we're working with our getters and setters, we have a special name for those in C#. In other languages, we always code these things ourselves and call them accessors and mutators, but in C# we have a special capability called a property. So a property looks like a method. It uses the same name as our instance variable, but we use an uppercase letter. Now, it doesn't have to be the same, but that's kind of our convention. So here is a property that is for the number of square yards. The number of square yards exists as a data value within this carpet calculator class. And if we want to set that value, we're going to be executing the setter code, which says, hey, take whatever value you were passed and update the number of square yards class field with that value, and the getter just returns it, gets it for whoever needs it. So this is a property. Now, a property can be accessed in a lot of different ways, and we'll see that as we go through our example looking at our animal class. We can have properties written out in many different ways. We can have this type of syntax here. I'll put that in our OneNote notebook, getting a little bit more notes than we've had in the past, huh? So I could have a public property, and then within that public property, I can say get, and in the code for that get method, I'll return the class level field, and then I can also have a setter. And in my setter, I'll update my class level field. So properties result in a lot of questions for people because it's a very new concept. Now let's fix some casing first. This P should be lowercase. My return should start with a lowercase r. My get and set should be lowercase. Now this is a property, and this is a fully articulated property here. And a property allows public access to our private class fields. Now, in our presentation, they show another way called auto-implemented properties, much shorter. You'll see those as we work on the code, so I'll let you add that again to the notes because I know you don't like to sit here and watch me type forever. Now, whenever we are working with auto-implemented properties, we might not have to include our private data members. We have an anonymous backing field automatically created, which just means that we're going to be allowed to do some checking before we take any sort of value and set that to our class level field. When we're working with C# classes, we can also auto implement or automatically set a default value for a specific field in our class with this syntax here. We'll try that. And then lastly, we have the ability to override system level methods within our user-defined classes. So for example, the toString method is called for a class automatically if someone issues a write or write line method on that class instance. And we can override that toString method to have it output information that's meaningful for our class. I'll show you how to do that with our animal class. Now there are lots of examples also in your textbook. This again is an area where we really need to be working with examples. As you look through the presentation, there are several more slides where they give you some syntax. If you want to copy those to your notes, I think that we're going to be better off using our animal example to test our class. So you, like I said, have this student app that's fully implemented in your textbook and in REPL for you to test. And you have some other tests in your textbook, like your carpet calculator, which it also has some additional videos. And then there's also this real estate investment example. In this chapter, I would suggest that you do as many examples as you can, because this is an area where we really start implementing an object-oriented thought process. And it can be a little bit different way of thinking, so it can definitely be something that requires a lot of practice to really wrap our heads around. But be sure to watch the next video where we talk about our animal class. Thank you.